Hey, welcome back to your favorite Fundamentals of College Math class. We're going to talk about measures of central tendency. So there's three common measures of central tendency. The mean, a lot of people call this the average, right? But our mean, our median, that's our middle, and our mode, most often, M-O, mode, most often value. Let's talk about mean first. So the mean is when you take all the data values, add them up, divide by the number of values, right? So we like to use X bar to indicate the arithmetic mean. By the way, there are different types of mean. We're only going to do an arithmetic mean. There is something called a geometric mean, which comes into play if you get into like finances and things like that, and geometric mean investments, average of investments over years. But anyways, our arithmetic mean here would be add all up these scores. Here's the scores on the exams. Divide by how many scores do we have? How many data values? 4. So our mean, our arithmetic mean here ends up being 79, 86, 82, 94. Divide that number divided by 4 gives you 85.25. And typically we like to round that to one more decimal place than the original data. Notice the original data has no decimal, so we're just going to go to 0.1 to the first tenth, right? Since the original data was to the ones, we'll go to the tenth, be a little bit more accurate. So it's approximately 85.3 is our mean there. Why don't you guys pause the video and go ahead and try the next one, find your mean. So if you notice, we add them all up, divided by 5 data values, should get 3.682. Now, normally we would round it to one decimal place more than the original data, but since this is dollars, and cents, we're going to round to the nearest cent, right? It has context, so we'll just round to the nearest cent. So the average or mean price of a jar of peanut butter was $3.68. Now here, if you notice, you've got a frequency table. You've got income in thousands. So if you were finding the mean by hand, boy, this could take a long time, right? Because you got 15,000 6 times. Plus, and now we got 20,000. There's 8 houses that made 20,000. So there's 8 of those. Anyway, so you can see this is going to take you a long time, right? And there's 100 of these total houses that we have. So how can we shorten this? Well, 15 plus 15 plus 15 plus 15 plus 15 plus 15 plus 15, did I say that 6 times? Is just 15 times 6, right? And then we've got, there's 8 of these 20s. So I'm going to add up 28s, or 8 20s, sorry, or 28, same thing actually. And I've got 25 times 11, I got 30 times 17, I got 35 times its frequency, I got 40 times 20, I got 45 times 12, and I got 50 times 7. And I divide that by how many total numbers do we have? We have 100 of these households that we got their household income from. So if I do that, if I punch all those in, 15 times 6 plus 160 plus whatever the next one is and so on, I'll get 3390 on the top divided by 100. So I get 33.9. Remember, this is in thousands. So the mean household income at this time, this is many years, quite a few years ago, is $33,900, right? So 33,900. So this example, now let's say we have the exact same data, but somebody moves in, new family moves in, and they're making all kinds of money, 5,000 thousands, right? In other words, they make $5 million, and there's only one of those families. How would that change things? So if I go through, I got 15 times 6 plus 20 times 8 plus blah, 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 50 times 7. And now I have this new person Elon Musk is moving in, making $5 million a year, right? Divided by how many households? Now there's 101 of these households, right? Add up all the frequencies there. How does this change the mean? Well, this will end up being 8390 over 101. So 83.069. So substantially different, right? Remember our last, before Elon Musk moved in, the mean household income was 33,900. Now it's 83,069 because Elon Musk moved in, this outlier that really messed up our data. Does that make sense? It's not very accurate. It's not a good measure of central tendency. So when you're looking at like household income, a better measure of central tendency, instead of using mean, instead of using the arithmetic mean and average, what you want to use is you want to use a median, the middle value. That's really a better measurement of central tendency when you're talking household income. So when you're finding the median, the middle number, if you have an odd amount of data, it's the middle, right in the middle. There'll be one middle number. Okay. If there's an even amount, there is no one middle value. There's two in the middle, and so you find the mean of those two middle values. And that's your median. Okay. And where is the position? The position of the median is the n plus 1 divided by 2. It's in that position. In fact, if you want to find the position, this is the first position, second, third, fourth, fifth position, right? Where's the position of it? Well, you could probably see it. It's right there in the middle of that third position, right? But if you wanted to figure it out, you say, well, there's 5 of these numbers, so it's going to be the third one, right? I have 3.29, 3.99, 3.75. There's the middle right there. All right, it's in the third position. I like to do it this way. I cross out them in pairs. I cross out the first and last, then I cross out the second one and the second to last. There's my median right in the middle. So the median price at these 5 stores is $3.75. Now, what if you have an even amount of data? So here I have 15, 20, 18, 16, so on. Now, this is not in order. If you notice on this, oh shoot, I just realized I didn't write that last one in order. Sorry guys, we better double check that. That was not in order. I gotta have these things in order first. 3.29, 3.59, 3.75. Oh, looks like I got lucky. 3.79, 3.99. First and last, first and last. There it is. I just happened to get lucky on this one. Make sure you order that dang thing first. All right, let's go ahead and order this one. So we got 12, and I got 14. Let's see, 12, 14, 15, 15. 15, 15, I got a 16. I got a 17, another 17, and I got an 18. So notice I have eight of these data value. Oh shoot, there's another, and an 18. Sorry, good grief, and a 20. Just kidding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 of these. 10 of these, right? So what's the position? It'll be in the 11 over 2, 5.5. So it's between the 5th and the 6th is where the median is, right? It's between the 5th and the 6th. We have an even amount. So again, what I like to do is I like to cross them out in pairs. Bottom, top, bottom, top, bottom, top, bottom, top. Okay, I got these 2 in the middle. There's no 1 in the middle. There's 2 in the middle, right? It's right between the 2. So what do? Take their mean. What's the average of those? 16 plus 17 divided by 2. 33 over 2, this is my median when I have an even amount. So 16.5 is the number right between those two, right? So the median is right there between them. Whoops, right there between them. Example 7 here, notice I have a frequency table, right? So I got 6 of these 15s. I got 8 of these 20s again. Remember, this is our household income. There's 100 of these households, right? I don't really want to write out 100 of these. That would be horrible, right? So where is the position of the median? What position is it in? N plus 1 over 2. Well, I have 100 of these households plus 1 over 2, so it's 101 over 2, so it's 50.5. So it's between, since there's 100, there's an even amount, it's between the 50th and the 51st, right? So it's between 50th and the 51st data values. So I need to find the average or the mean of those two data values. Well, who is in the 50th position? Well, if I write this out, I have 15, 15, 15, 15, 15, and 15. So there's 6 of those, right? So the 6th position is my last 15. Then I go to 20s, and I got 8 of these. 20, 20, 20, 20, 20, 20, 20, and 20. And that'll be 6 plus 8. That'll be my 14th position, is my last 20. And then I'm going to 25s. 25, blah, 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 blah. So if I add these up, like 6 plus 8, my last 8 is 14. 14 plus 11 gives me 25. My last 25 number is in the 25th position. 25 plus 17, 42. My last 30 will be in the 42nd position. 42 plus 19, 61. 61 plus 20, 81. 81 plus 12, 93. 93 plus 7, 100. So my last number will be a 50, of course, right? So where is my 50th and 51st values? Well, my 43rd number, well, I'll start, let me do the 7, see the 42 right here? 30 is my 42nd number. And then I go to 35, and my 35 is my 43rd number, and it just keeps going, and my last 35 is in the 61st position. So my 50th and 51st numbers will both be 35s. So the median would be the 50th number plus the 51st number divided by 2 would be their average, which of course 70 divided by 2 is just 35. So my median is $35,000. Right? My median household income is $35,000. If we did it with Elon Musk being thrown in, right, the $5 million household income. Well, now we have 101 of these. So the position would be of the median. The position of the median would be n plus 1 over 2. So we had 101 over 2. So 101 plus 1, over 2 is 102 over 2. So it's the 51st position. So who's in the 51st position? 35. So even with Elon Musk, this is a much better measure of central tendency, because the measure of central tendency here being the median is 35,000. Better measure of central, right? With household income, even with the outlier thrown in. All right, the third measure of central tendency is mode, M-O, most often. Which data value occurs most often? Okay, so let's look at our vehicle color data. can you see how we have 25 blues, 52 greens, 41 reds? Who's the most? Maybe I should do it in green. I'll do it in green. The most, oops. Is the green. Green is the mode. The green color cars most often data value that occurred. Yeah. Now you should note there is no mode. There is no mode if there's no data value that occurs most frequently. And if you have data values that have the same amount, but they're the most, then you can have a couple of different modes, depending. Like this is an example of that. So I have 2 2s, I have 2 3s, and I have a 5, and I have a 6. 2 2s and 2 3s. So both of those are the mode. They both occur most often. But they're tied for the same amount. They both have 2 of them, right? But they are more often than the 5 and the 6. There's only 1 5 and 1 6. What about this? 2 3 5 and 6. Well, there's only one of everybody. So there is nobody that stands out. There is no mode here. So with measures of variation, we're just going to measure spread. There are a couple ways to do that: standard deviation, range, quartiles. We're going to talk about range and standard deviation. So again, how much spread do we have? So this is a good example here to start with in finding our range here. Which is the difference between the maximum and the minimum. Okay, so if you notice section A, for A, the max is 5 and our min is 5. So the max minus the min here is the range for A data is 0, right? For B, the range for B, our max minus the min, our max is 10, our minimum is 0. So we just have a range of 10 on that. On C, our range on C, our max is 6, our min is C. I'm sorry, it's 4. So we have a range of 2. Now the interesting thing about all 3 of these is all of them have a mean. They have a mean of 5 and a median of 5. So the range can be revealing, right? Because it's kind of showing how spread out the data is. So the range can be helpful, right? Because you would think with a mean of 5, median of 5, they'd be pretty similar. They're not. And even better, look at how spread out the data is the standard deviation. Okay, because these are obviously the range is giving us some idea of it, but the standard deviation is the average deviation from the mean. That's your definition of the standard deviation. And so that'll kind of illuminate the differences in a more sophisticated manner. So as I mentioned, the standard deviation, what is it? It's your average deviation from mean. So each data point, how much difference is there between it and the mean? On average, right? What's that spread? So here's some characteristics. Number 1, standard deviation is always positive, and the standard deviation will be 0 if all the data values are equal. All the data values are equal. Standard deviation has the same units as the original data, and like the mean, it can be influenced by outliers. So Elon Musk household income would heavily influence depending on how much of an outlier it is, right? Your standard deviation. So just note that. Now, what we're going to do is we're going to compute it, and you have two types of standard deviation. One is for a sample. So let's say you're running a study on all of CSN students, but you only take a sample of, let's say, 100 students. Then you would want to use the standard deviation for a sample. That's pretty typical. The only difference between these two is this one's divided by n minus 1. When you're doing a population, you're only dividing by n here. Okay. So population would be if I have data for every CSN student, right? Then I would want to use that bottom standard deviation. Okay, but how do you do it? Well, the first thing we're going to do is we're going to find the deviation. The second thing is we're going to square the deviation. The third thing is we're going to sum up all those deviation squareds. Third thing is we're going to find the variance, it's called. So we'll divide it by, in this case, n or n minus 1. And then finally, we'll take the square root, and that'll give us the standard deviation. Okay, a couple of notes. If you're not sure whether the data is a sample or a population, or it's not telling you which kind of standard deviation to use, you can just assume it's a sample. That's your typical one. Your Greek letter right there, that's the lowercase sigma. That's the lowercase sigma. All right, so here's the section D data, and we're going to find the standard deviation for the sample, and we'll go ahead and do the standard deviation for the population. So my data, here's all my data. So first thing is I list all my data in that first column. See how it's all listed: 0, 5, 5, 5, 5, 5, 5, 5, 5, 5, and then a 10, right? Now the second thing I'm going to do is I'm going to find the deviation. So I'm going to take that data value and I'm going to subtract it from the mean. So I'm going to have to know what my mean is of this data. So let's find the mean. 0 plus 5, it looks like there's 8 of those 5s, plus a 10, and there's 10 data values, divided by 10. And so it looks like I got 50 over 10, so our mean here is 5. That's the first thing. So let's find our deviation from the mean for each of these. So the data value minus the mean. So I got negative 5. The next data value is 5, so 5 minus the mean. All of these will be the data value minus, so all of these will be 0, 0, 0, 0, 0. And then finally, this data value minus the mean. Give me 5. Okay. Now what I'm going to do, so far if you're looking at this formula, we have the sum of x minus x bar. I've done the x minus x bar. I got to square it now, and then sum all that up. That's the Greek letter sigma, capital Greek letter sigma means sum it all up, and then I'll divide it by n minus 1, and then I'll square root it. Okay, but let's do the square part first. So I'm gonna take those values and square it now. So I got negative 5 squared, so I got 25. And then I got 0 squared, 0, 0 squared, 0. So all these will be 0 squareds. And then I got 5 squared, which is 25. Okay. Now I add all these up. Let me add them all up. So my total, and that's the sigma part. That's the sum of. Sum all those up. 25 plus 0, 0, 0, 0, 0 plus 25. I get 50. Okay. So let's go to our formula. The standard deviation for a sample is the square root of the sum of the deviation squared over n minus 1. So we just got that number right there. We summed all those deviations squared. So we got 50. That's a really bad 50. 50, there we go. Divide by n minus 1. Well, n is how many data values do we have? We had 1 0, we had 8 5s, and we had a 10 at the end. So there were 10 data values, right? So we're going to take the square root of 50 over 10 minus 1. So we got the square root of 50 over 9. So I go ahead and punch in 50 over 9, take that square root, and that'll end up being 2.357022604. Make sure, again, you punch in the square root of 50 over 9. And that'll be, you know what, we'll round this to 1 decimal more than the data. So 2.4. So that's our sample variance, or I'm sorry, sample standard deviation. This one is our, when we divide just by n, that's for a population. So let's do the same thing. I take that same 50 number on the top, but this time I divide it by n. Well, in this case, n is 10. There's just 10 data values. So 50 over 10 is 5, so it's just the square root of 5. So my population standard deviation is the square root of 5, which is 2.236067977. So about 2.2. This would be a good problem to have you guys try it. So first thing, you're going to have to know your mean. So you go ahead and add up 10, 12, 15, 17, 21, 26, divided by, it looks like there's 6 numbers. So our mean here is 16.83 repeated. That's number 1. Now let's go ahead and make our table. So we're going to list all our data values. I like to do it in order. 10, 12, 15, 17, 21, 26. And then what we're going to do is we're going to find the difference between that data value and the mean. Again, this is called our deviation. So we're going to go 10 minus 16.83. I need more room here. So I got negative 6.83 repeated. And then I'm going to go this data value 12 minus the mean 16.83 repeated. So I get a negative 4.83 repeated. And I keep doing that. Now that I've done that, I'm going to need to know the deviation squared. So I'm going to square each of those. So I got negative 6.83 is being squared now. That'll give me 46.694 repeated. Then I'm going to take that negative 4.83 right there. I'm going to take that deviation, square it, and that'll give me 23.361 repeated. Then the negative 1.83 squared. And the 0.16 repeated squared. 4.16 repeated squared. And then 9.16 repeated squared. And I need this total. So I'm going to add up all these numbers right here. Add all those up and you'll get 174.83 repeated. Okay. Now let's go back to what are we trying to find? We're trying to find our sample deviation, which is the square root of the sum of x minus x bar squared over n minus 1. So that would be the square root of that 174.83 over n. How many data points do we have? How many numbers did we have at the beginning? We have 6, 10, 12, 15, 17, 21, 26. We have 6 of those. So divide it by 5. So 174.83 divided by 5, and then take that square root, and you'll get your standard deviation. Ends up being 5.913261931. So about 5.9. And then you can also do your standard deviation for the population, which is that same 174.83, but instead you're just dividing by n. Oops, that's repeated there. Repeated. So divided by 6. Divided by 6. All right, let's take that section B data, and this time let's do the mean, median, and standard deviation in Google Sheets. So the first thing you want to do is you want to enter the data. I'll show you how to do this. And then to find the mean, what you want to do is you want to say, tell it to find the average, and then you tell it where the data is located, the average of those numbers. To find your median, the instructions are equal median, and then you tell it where to find the data. To find the standard deviation of a sample, you say equal STDEV, and then you tell it what data from where to where in that column. For the standard deviation of a population, you tell it equal STDEVP, and then you tell it on what data. Okay, so I'll go through that. Let me pull up Google Sheets here. If you have a Google account, you can do this for free in your Google Sheets. Let me open up a blank one here. All right, I'm going to put my data in. I had 0. I'm just going to put it into column A. 0, 0. I had 5 zeros. And then I had a 10, a 10, a 10, 10, and a 10. So I put my data in. Notice my data is in column A1 through A10, right? So I'm going to go over here. Let's go ahead and, oops, no, what'd I do? Let's find our mean. Let me do it over to the side here. So I'm going to go equal average, and I'm going to go A1 colon A10. And see how it highlights that? And I'm going to end my parentheses right there, A1 to A10. Let me see if I can blow that up a little bit. There we go. That's better. Enter. Okay. Let's see. Let's do the median now. Median equal median A1 to A10. There's my median of those numbers, right? Which the median would be between, it'd be the average of 0 plus 10 divided by 2, right? That would be our median or middle on that one. Our standard deviation of a sample equal STDEV, A1, A10. There it is. Oh, that is nice, right? Because you know how annoying that could be to find. And let's do standard deviation of a population equal STDEVP, A1 to A10. And there's your standard deviation of this population is actually 5 here. And I'll show you the coding out to the side here. Formula text for D2, and that shows you the formula. That's right there, equals formula text for D4. That shows you the code right there. Formula text for D6, there's that one. And formula text for D8, there's that one. All right, so that's how you do that in Google Sheets. And thanks so much for watching, and we'll see you guys next time.